Today we're going to talk about acceleration. Acceleration is the rate at which velocity changes. So to remind ourselves about velocity then, we need to remember that velocity is distance divided by time, and it includes a direction. So acceleration is going to be either when I change my speed, so speed is not constant, or I'm going to be changing in direction. So if my speed or my velocity changes, which is going to be my direction, acceleration is going to also change. So I have a formula to represent this, and it is A equals VF minus VI over T. So we want to talk about what each one means. A is for acceleration. VF, so the F here is a subscript. That is my final velocity. So the velocity at the end of whatever scenario we are given. VI, I is for initial. So this is my initial velocity, or the velocity at the beginning of my situation. At the bottom I have T, which is going to be for time. So let's talk about those units. Acceleration will be measured in meters per second squared. Both of my velocities will be measured in meters per second, like we are used to, and time will be in seconds, like we are also used to. So my first example here, it says, during a race, a sprinter increases her speed from 5 meters per second to 7.5 meters per second over a period of 1.25 s or seconds. What is her average acceleration? And that's what this equation tells us, the average acceleration of that individual. Not how much are they accelerating right now, but over that entire 1.25 seconds, how much what is her acceleration? So for each one of these, we want to identify each of our variables, so what we know and what we don't know. So in this case, they're asking, what is her acceleration? So I don't know A. VF, my final velocity, that's the velocity at the end of my scenario. So I go back to my problem and I see that I have some numbers. So I need to decide which one belongs there. Well, final velocity again, end of my situation. So she's going from 5.0 meters per second to 7.5. So this is my final velocity. My initial velocity, the velocity at the beginning of this person's situation, is 5 meters per second. And the amount of time that she takes to change from 5 to 7.5 is 1.25 seconds. Once I know those numbers, I can plug them into the formula, since this equation is already solved for A, and that's what I don't know. So I'm going to plug in my numbers here. So VF is going to come first, 7.5 meters per second, minus my initial velocity, divided by the amount of time, 1.25 seconds. So I have 7.5 minus 5. To give me 2.5 divided by 1.25. And you're always going to be able to use a calculator on these, just like our velocity problems. But in our heads, we can do 2.5 divided by 1.25 to give us an answer of 2. And my unit is meters per second squared, since this is acceleration. And then I want to put it in a box so everyone knows that's my final answer. Let's try another one. Example 2. As a shuttle bus comes to a normal stop, it slows from 9 meters per second to a stop in 5 seconds. Find the acceleration of the bus. So I have my equation written here for me again, and I have I don't know acceleration. That's what they want me to find. I need to figure out what these other numbers are. So when I look at my final velocity, so this is what is the speed of the bus at the end of this situation? Well, it's coming to a stop. So what would that velocity be? It would be 0. Initial velocity, it's starting at 9 meters per second. And the time it takes for that to happen is 5 seconds. So I've set up a skeleton like I did before, so my final velocity comes first, so this would be 0 meters per second minus VI, or initial velocity, which is 9, divided by my time in seconds, which we said is 5. So in this case I have 0 minus 9, so I have negative 9 meters per second on the top, divided by the amount of time, so 5. This one is a little more difficult, so we're going to put it into our calculator to get negative 1.8 meters per second squared for my acceleration. So when we see that negative number, typically we think, am I supposed to get a negative number for this? In this case, that's okay. I can have negative acceleration. And what does that mean? It means that my object went from whatever it started with, it slowed down, so the final velocity is a smaller number. So that can give me a negative number on the top, which gives me a negative acceleration, and that's okay. Let's try another one. As we've seen with our speed examples, we're not always going to be able to use the equation just as it's given. So in this example, I have a dog runs with an initial speed of 1.5 meters per second. So I'm going to write that down right now. Initial speed, 1.5. Okay, so 1.5 meters per second on a waxed floor. It slides to a stop, so final velocity is 0. With an acceleration of negative 0.35 meters per second squared. So this is much different. I'm not solving for acceleration now, they gave it to me. So what am I solving for? Well, I see right here I'm solving for time, but I can also tell from the story. How long does it take? That's going to be time for the dog to come to a stop. So T is what I don't know. So I use my algebra skills to move this around. So I'm going to look at my equation, circle what I don't know, and rearrange it. So I have T on the bottom of a fraction. How do I get it out of the bottom? Multiply by T on both sides, which is kind of messy. If I have T on the top and the bottom, they cancel. So as it's written right now, I have A times T equals VF minus VI. Well, I don't want to know A times T, I just want T by itself. So T is being multiplied by A, so I divide by A on both sides, so that A over A is 1, and now I do have T by itself. So time is equal to final velocity minus initial velocity divided by acceleration, which I have set up over here. We're going to plug in our numbers. So final velocity was 0. Initial velocity is 1.5. Acceleration is negative 0.35. And then I'm going to use my calculator for this to figure out the amount of time. So 0 minus 1.5 is negative 1.5 divided by negative 0.35. My calculator tells me 4.285714286. So I can round that. I'm just going to round it to 4.3. I'm going to put my answer in a box, and I'm done with that one. Example 4. Same idea, I'm going to have to rearrange this. A babysitter pushing a stroller starts from rest and accelerates at a rate of 0.005 meters per second squared. So I'm going to write that in right now, 0.005. meters per second squared. Starts from rest, so her initial velocity is 0. What is the velocity of the stroller after 4.75 minutes? So I have my time, 4.75 minutes. Notice this is not in seconds, so we're going to address that down here. What I don't know is final velocity. Okay. So before I go plugging in any numbers and any equations, I want to make sure everything's in the right unit. So time is not. So I need to figure out 4.75 minutes is how many seconds, because this equation needs seconds. So I set up my conversion factor. 4.75 minutes is equal to 60 seconds over 1 minute. 4.75 times 60 gives me 285 seconds. So that's not my actual time. I want to use seconds for that. Okay, now I want to solve my equation for final velocity. Starting out with the same step we just had. Whenever I have a fraction, I want to get rid of that because fractions make things messy. So I put multiply both sides by t. By doing that, I have t over t, which equals 1. So now I have a times t equals vf minus vi. That looks familiar. But this time, I'm solving for vf. So I should have circled that to begin with. I'll circle it here. If I want this by itself, I need to reverse whatever's being done to it. Right now, vi is being subtracted from it, so what I need to do is add vi to both sides, because negative vi plus vi is 0. So that is nothing now. I have vf equals a times t plus vi. Okay, so I've set that up over here. So vf is equal to a, which is 0.005 meters per second, times t, which we figured out is 285 seconds, plus initial velocity, which they told us we started at rest. Rest means 0. So plus 0 meters per second. So I have 0.005 times 285 plus 0. So I grab my calculator to give me 1.425. So I'm going to round that to 1.43 meters per second. And that's my final answer. For this last one, you're going to do this one on your own. So pause the video, write down the problem, and complete it in your notes and bring it with you to class.